In this video we're going to talk about differentiation rules. These are sometimes called shortcut rules, because up until now you've had to use the limit definition every time you wanted to take a derivative. Now you're going to learn some easier ways to do it. Alright, the first rule we're going to talk about is called the constant rule. And all the constant rule says is that the derivative of any constant, which we'll use the letter C, is 0. And if you think about it, it makes sense, because remember, the derivative is a slope. And any time you have y set to a constant, it's always a horizontal line, and the slope is 0. So for example, if I have y is equal to 7, then y prime, the derivative, is just going to be 0. Similarly, for f of x equaling to 4, let's say, f prime of x is equal to 0. Let me just get another pen here. I got a pencil. And one that kids kind of always mess up is this one. If I ask you for the derivative of pi, well, kids somehow think that pi is a variable like x or s or something. It's not. Pi is just a number also. So the derivative of pi is also equal to 0. Okay? All right, our next rule is we're going to call our single variable rule. And if I were to say to you, what is the derivative of any variable? Well, think about it for a second and say, all right, well, what would the slope be if I graphed y is equal to x? Well, you think about y is equal to mx plus b, and the slope would just be 1. So the derivative of any variable is 1. That's the variable rule. So just to illustrate a couple of examples, if y is equal to x, y prime 1. If s of t is equal to t, then s prime of t is equal to 1. You're probably getting bored by now, so let's keep on moving. All right, our third differentiation rule is called the power rule. This is probably one of the most important. All the power rule says is that if you take the derivative of some variable to the nth power, all you have to do is take that exponent, put it in front, and subtract 1 from it. And that might be a little weird to see symbolically, so let's go ahead and look at a few examples. If I have y is equal to x squared, now the power rule says to take the 2, put it in front, so we know that y prime is going to be 2 times x, and subtract 1 from the 2. 2 minus 1 is 1. So the derivative of y equal to x squared is 2x to the first power. I just put the 1 there, but normally you wouldn't write that. Let's try this. If I were to say to you f of x is equal to x to the 6th, then f prime of x is equal to 6x, subtract 1, to the 5th. Notice the exponent went in front, and then we subtracted 1 from it. Alright, now these are kind of easy examples. So what I probably suggest you do is I'm going to write down a couple more. After you see them all, pause your video and go ahead and try them, and then start the video again to see how I do them to make sure you can get them right. Let's do y is equal to 1 over x. Let's try f of x is equal to 1 over x cubed. And how about, I don't know, s of t is equal to 1 over the cube root of t. So if you think you can handle these on your own and want to give it a shot, go ahead and pause your video and then come on back. I'm going to go ahead and start doing them. Alright, sometimes before you differentiate, it helps to kind of simplify first and write all of these looking like some sort of a power of x. So if I were to rewrite y here, now notice I didn't take the derivative yet, there's no y prime there. This is just another form of y. we can write that as x to the negative 1 power. Now it might be a little bit easier to see that y prime is going to be the negative 1 is going to come in front. X, negative 1 minus 1 is negative 2. And usually what you always want to do is leave it in the form that you started with. So here we had positive exponents. We want to leave this with positive exponents too. So we can just rewrite that as negative 1 over x squared. Alright, here f of x was 1 over x cubed. So I'm just going to rewrite it so I can look at it a little bit easier. And that's just going to be x to the negative 3. Now I can get ready. Now I'm ready to go ahead and differentiate. So f prime of x is going to be negative 3x, subtract 1, negative 4. And don't forget to put it back the way you found it. F prime of x rewritten is going to be negative 3 on the top, and we're going to put that x to the negative 4 in the denominator with a positive power 4. Here this one may look a little weird. You don't forget to, well, not don't forget to, I never told you to, but when you have radical notation, sometimes it helps to switch to exponential notation, to switch to rational exponent notation. So let me rewrite s of t as 1 over t to the 1/3 power. And now if I want to write it all in the numerator, that's going to be t to the negative 1/3 power. Don't notice I haven't even differentiated yet. Now I'm ready to go ahead and differentiate. S prime of t, that's going to be equal to, now the negative 1/3 comes in front, t, and you just got to think about it with your common denominator, negative 1/3 minus 1. Well, to write 1 with a denominator 3, that would be 3/3. So it's going to be negative 1/3 minus 3/3. Well, negative 1 minus 3 is negative 4. That's going to be negative 4/3. Now we got it. It was given to us in radical notation, so let's go on back to that. So we know that s prime of t is going to be equal to negative 1 over 3t to the 4/3 power. And one more time to be done. This is the index, this is the exponent. So we can rewrite this as negative 1 on the top, and on the bottom we're going to have 3 times the cube root of t to the 4th power. And there's your final answer. That was a little bit of algebra, but it's really not that bad, and the concepts are the same. Alright, let's keep on moving. Okay, we did the power rule. Now let's take a look at the constant multiple rule. Yeah, let me get this centered. Okay, the constant multiple rule. All that says is that if you're asked to take the derivative of some constant times a function of x, you can just ignore that constant, and your derivative is going to be that constant times the derivative of the function. So basically the constant just comes along for the ride. You can just ignore it. Okay, let's look at a couple of examples. Let's say I had y is equal to I don't know, let's say 3x squared. Well, again, the constant multiple rule says we can ignore that 3 and just go ahead and take the derivative of this piece right here. Well, we learned the power rule for this. So y prime is going to be ignore the 3, take the derivative of this piece. So it's going to be the 2 comes in front, and we subtract 1 from it. And lastly, go ahead and simplify. 3 times 2 times x is 6x. To look at it with a slightly different problem, let's look at y being 2 over x squared. Let's first rewrite that. 2 times x to the negative 2. And now we're ready to differentiate. Y prime, the negative 2 is going to come in front, times 2x, subtract 1, negative 3. So our derivative is going to be negative 2 times 2, which is negative 4, x to the negative 3. They gave us positive exponents. Let's make sure we give them back positive exponents. So it's going to be negative 4 over x cubed. I don't know how much I want to beat this dead horse. Let's go ahead and just look at one really hard one. And, you know, actually, you know, let's go look at a couple of them. I'll write them down. Maybe you want to pause the video, go ahead and work them yourself, and then we'll come back to this. So, let's see. Why don't you try this one? Let's say y is equal to negative 5 over 3x cubed. And let's also give you y is equal to 4 times the square root of x. Go ahead and pause the video, work these couple of problems, then go ahead and play the video, see if you do it right. Alright, let's see if you did it right. Now, let's write this as a kind of like a cleaner monomial with the like we've been doing. So, the negative 5 over 3, we're just going to write that as a coefficient. And that's going to be x to the negative 3 because I brought it up to the numerator. Now this negative 3 can come in front. We're going to have y prime is equal to negative 3 times negative 5/3 x subtract 1 negative 4. Well, the 3's cancel. The negatives times the negatives are positive. So what we have is positive 5x to the negative 4. And putting it back the way we found it, 5 over x to the 4th. Over here, let's write it, let's go from radical notation to rational exponent notation. So this is the same thing as 4x to the 1/2 power. So y prime, I'm ready to differentiate. The 1/2 comes in front, times 4x subtract 1/2 minus 1, well that's 2/2. So 1/2 minus 2/2 is negative 1/2. Now we just have to simplify this. The 1/2 and times the 4 gives you 2 over x to the 1/2 power, and that's the same thing as 2 over the square root of x. Alright, while we're on the subject, a really handy derivative to remember is that the derivative of the square root of x is 1 over 2 square roots of x. Now you could do it with the power rule like you just saw, but for some reason this derivative comes up all the time, so it pays to kind of commit it to memory. It'll make your life a lot easier in the long run. Okay, last rule and then we'll call it quits for this video anyway. Let's talk about the sum and difference rule. What's that? Roman numeral 5, sum and difference rule. All this rule says is that if you take the derivative of some sum or difference, so plus or minus f of x, I'm using a little shortcut notation there so I don't write 2 rules instead of 1, that's just going to be the sum or difference of the derivatives, so you can just do them separately. So if I have y is equal to x squared plus 5x minus 3, y prime, the sum and difference, says I can just do each one separately and report it as a derivative. So you just do them one at a time. The derivative of x squared is 2x by the power rule. The derivative of 5x is just going to be 5. And then the derivative of negative 3 is just 0. So there's your answer for that one. I did them both. I did all 3 at one shot. Let's try another one. Let's say, what if f of x is equal to, let's say, x to the 4th minus 3/2 x cubed plus 2x squared plus x minus 6. Let's do them one at a time. F prime of x is going to be power rule 4x cubed, constant multiple in the power rule all in one. 3 comes in front, So that's going to be what, negative 9/2 x to the x squared. 2 comes in front, plus 4x to the first power. The derivative of x is just 1, and the derivative of any constant is just 0. Alright, why don't I give you a couple of examples and you try them. They're a little tricky with some notations, so take your time. Let's say 6 times the square root of x times the cube root of x minus 2x plus 6. And let's see another little tricky one. How about f of x is equal to 2x minus 3 squared. Now you have all the skills you need to go ahead and differentiate both of these. So pause the video, think about it, struggle through it, give it some time, see if you can't come up with a derivative. Alright, let's take the derivatives. Y prime. Well, I don't want to rush into the derivative here because I got something going on here that I haven't seen before. I've only seen the sum and difference rule, plus or minus separate terms. This has got 6 times the square root of x outside, and on the inside we have all this mess. So let's just think about it as this. Let's just go ahead and distribute out that 6 square roots of x to all these, and then you'll have something that looks a little bit more like a polynomial. Alright, 6 square roots of x, well, that's the same thing as 6x to the 1/2 power. And this is going to be x to the 1/3 power minus 2x plus 6. Now I'm ready to distribute it. 6x to the 1/2 times x to the 1/3, rules of exponent says you add these. Don't forget, I haven't differentiated yet. I'm just simplifying first. So 1/2 and 1/3, what's that? 3/6 and 2/6. So that's 5/6. That's going to be 6x to the 5/6 power. 6 times negative 2 is negative 12. X to the 1/2 times x would be x to the 3/2. And 6 times 6 is 36. X to the 1/2 power. Now I'm ready to go ahead and differentiate. Let me go ahead and move this up a step. Alright, y prime, here we go. The 5/6 comes in front. 5 times 6 is 30, divided by 6 is 5, so you're going to have 5x. 5/6 minus 6/6 is negative 1/6. The 3/2 comes in front, and we're going to have 3/2 times 12, which is going to be, what's that? 36 divided by 2 is negative 18. X, 3/2 minus 2/2 is 1/2. And then this 1/2 comes in front. 1/2 times 36 is 18. 1/2 minus 2/2 is negative 1/2. Okay? Now let's go ahead and clean this up a little bit. We found it in radical notation, so let's go ahead and do that. So this is going to be 5 over the 6th root of x minus 18 times the square root of x plus 18 times over the square root of x. And that ought to do it, right? Did I mess anything up? I almost cursed on video. Alright, no, that's good. Alright, so let's go ahead and look at this one. Now this one, notice you have a power and you have another function inside here. So before you can differentiate, square this out. F of x all squared out is going to be 4x squared. Negative 6x and negative 6x is negative 12x. Make that a little darker for you. And then negative 3 times negative 3 is positive 9. Now we're ready to differentiate. F prime of x is going to be equal to 8x minus 12 plus 0. So we're all set. There's your derivative. Alright, that's enough of the basic differentiation rules for now. On the next video, well, you probably should watch the next video, which is part 2. It'll give you the product and quotient rule, and also give you some applications that'll help you out. You're likely to see basic tangent lines and stuff. Okie doke.